The last thing I'd like to do is to demonstrate that the linear regression slope estimate is beta 1 hat equal to the correlation between y and x times the standard deviation of y divided by the standard deviation of x. I'd like to demonstrate that. It's going to take some doing, and if you don't want to get this involved in the mathematics, now would be the good time to stop the lecture and move on to the next one. However, if you are interested, again, I'm going to do this in a way that doesn't require advanced mathematics, but you have to be familiar with mathematical notation and pretty comfortable with it. So before I do full regression, let me do regression through the origin. I'm going to draw this line here. So I want to fit the best line, y equal to x beta, through my data. My data is y1 up to yn and x1 up to xn. I would like then to minimize the criteria summation yi minus xi beta squared, where the sum is from I equal 1 to n. Let me let beta hat be the solution, and we'll see what has to happen about that solution to make it work. So this equation here is equal to the summation I equal 1 to n yi minus xi beta hat plus xi beta hat, simply because I've just added 0 minus xi beta squared. All I've done is add 0. I can expand this square, summation I equal 1 to n, yi minus xi beta hat squared, and I'm going to distribute my sum, minus twice summation I equal 1 to n, yi minus xi beta hat times xi beta hat minus xi beta plus the summation xi beta hat minus xi beta squared. Now, if I get rid of this term, it's adding up a bunch of positive things. I'll only get smaller because I'll have thrown away something that's positive. So if I take 6, which is 4 plus 2, and throw away the 2, I've gotten smaller. Okay, let's look at this term right here. If beta hat forces this term to be 0, then let me just rewrite this. If it's 0, I will get the following. I'll get that my least squares criteria for any beta is larger than what I get when I plug in beta hat specifically. So that beta hat would have to be the minimizer, because every other beta is it creates a least squares criteria at least as large or larger. So if we can make this term 0, then we've found our estimate. So I want to solve summation I equal 1 to n yi minus xi beta hat xi times beta hat minus beta. I would like to solve that equal to 0. This term does not depend on I, so I could divide it from both sides of the equation and it would simply go away. Solving this equation for beta hat yields the solution summation I equal 1 to n yi xi divided by summation xi squared. I equal 1 to n. So that yields our beta hat for regression through the origin. Let's consider an example. that we've already shown otherwise. So imagine if x1 all the way up to xn are all equal to 1. Then my equation where I want to minimize summation yi minus xi beta, my regression to the origin equation works out to be summation yi minus beta quantity squared. It's mean only regression. Our result says that beta hat for regression to the origin in this case is summation yi xi divided by summation xi squared, which in this case is summation yi divided by summation xi squared. Xi is 1, so 1 squared is 1. And if I add them up, I get n, so it's y bar. Simply reiterating our proof earlier that y bar is the solution to the least squares criteria for mean only regression. So let's consider general linear regression. Here's our equation for our line, and here's the least squares criteria that we would like to obtain. We'd like to find the beta naught and beta 1 that minimize that equation. Our work already is going to make this very easy. Imagine for the moment that beta 1 is fixed and known. Then I'm simply going to rewrite this equation as summation I equal 1 to n yi minus beta 1 xi minus beta naught quantity squared. And then I'm going to write that as summation I equal 1 to n y star minus beta naught squared, where y star is equal to yi minus beta 1 xi. We know the least squares solution to this equation. It has to be, the solution has to be, beta naught has to be equal to the average. I forgot my I subscript there, so why don't I put it right there and right there. Has to be the average of the yi stars. Let's plug back in what yi star is. It's summation yi minus beta 1 xi divided by n. If I distribute out that sum, I get y bar minus beta 1 x bar. So my least squares criteria is only going to get smaller if I plug in a beta naught that satisfies y bar minus beta 1 x bar. So why don't I do that? And I get summation I equal 1 to n yi, and now I'm simply going to plug in my new beta naught because I know that whatever solution beta naught and beta 1 are, they have to follow this relationship, which is again saying that the fitted regression line has to go through the average of the y's and the average of the x's. So it's yi minus the beta naught that I just solved for, y bar minus beta 1 x bar minus beta 1 xi. So we know our solution has to do that. Now, this is equal to summation I equal 1 to n yi minus y bar minus xi minus x bar times beta 1 squared. And I forgot my square right there. Now, and I'm going to put some parentheses here. I'm going to rewrite this again. This is summation I equal 1 to n y tilde minus x tilde I, in both cases, times beta 1 squared. This is exactly regression to the origin, where now my outcome is y tilde and my predictor is x tilde, where yi tilde is equal to the centered y's, yi minus y bar, and my xi tilde is equal to the centered x's, xi minus x bar. Well, we know what the least squares estimate for this equation is. The beta 1 hat has to be summation yi tilde times xi tilde divided by summation xi tilde squared. Let's just plug in what yi tilde and xi tilde are. That's summation yi minus y bar times xi minus x bar divided by summation xi minus x bar squared. Thus, I can divide both sides by n minus 1, the numerator, both the numerator and the denominator by n minus 1. And this works out to be the covariance between y and x divided by the variance of x, which I can write as the correlation between y and x times the standard deviation of y over the standard deviation of x. So my beta 1 hat has to be this, the formula that we gave. Then my beta naught hat is given above as y bar minus beta 1 hat x bar